Holy shit, this song goes hard. All right. It's time. All right, let's get it. Time for the self-test, yo. Once I'm done with recent chapters, I'm going to go back to the beginning and do some stuff from there. And in my comment here, I'm going to be more specific about telling me what I got wrong. Because I don't have time to read all the individual, yeah, you said this, and it's all right, and there's this little, like, teeny piece in there that's, like, slightly inaccurate. Dude, I don't have time to analyze and do a dang text, does it equal, what is it called? Text, compare text. This shit. I don't have time to do that. Diff checker, there it is. I don't have time for that. I need to know what I'm saying that is wrong, smack my hand and say no, and tell me what the right answer is. That's what I need. Sort? I don't know how to... Sorts to... Oh, sort. Oh, sorts to integers. It just returns them in the order this or this. Oh, okay, cool. Alright, I was like... I haven't done any sorting, bro. Alright. I could try, though. Alright. Just not a lot of integers, because then I have to... I need an array, because an array, I can just keep adding to it. But integers, I have to hard code each one. So there's no way for me to know if you need 10,000 or 10. Oh wait, we'll comment first, yo. Okay, please. Critically evaluate my answers and specify exactly what I've said that is wrong. Or what I should have said, or what my response was missing. And why. Sure. Working backwards. Ah, fuck. Each one is... that's fine. This is good enough. 12.11. Oh, excuse me. Sorry. Alright. Pass in integers. And sorts them, meaning just prints them? Prints the order? Or I'm saying... That has to be the case, right? Because I can't actually replace them. I mean, I could say int1, int2, pass int1 and int2 references to them, and then if int1 is greater than int1, nothing. Return whatever, nothing. Or, and this would be a void function, or if 2 is greater than 1, then temporary variable to equal 2, 1 is now equal to 2, and then, or sorry, yeah, 1 is equal to 2, and then the temporary variable is assigned to 1 to flip them. Alright, so we'll say, in this case this is void and it just takes a parameter. We're not returning. What are you looking at? Oh, chapter 12 summary and quiz. I'm not even there yet. Okay. Source to integers by reference? I need more information than that. But if we're sorting, we're just going to say it returns them in the order. Sure. Void print sorted integers. I need I don't want to change them, so const int reference int 1 const int reference int 2. And if int 1 is greater than int 2, yeah, we output int 1 int 2. Okay, else if int 2 is greater than int 1, sure, int 2. Oh, I guess I could say do I say if this, then do this, if this, then do this, or do I say do this? Yeah, that makes more sense. Excuse me. If int 1 is not equal to int 2, then output. Oh wait, but I have to do both. I can't say. No, I guess that was right, because I have to do 2. Oh, I guess I could say. Nah, I think it does have to be this way. I'll say why in a sec. And then else int 1 and int 2 equal. Right, so we could do cool. 2 and 1. Oh, well, regardless, it doesn't even matter. Hold on. Oh, we're not gonna know. Well, so if we do 1 and 2. Oh, well, it's gonna. Well, yeah, and then if we just say 66 and then 3. I mean, this is kind of shit, isn't it? Sorts to integers by reference? What if we do it a cooler way? Yeah. Void sort integer refs. Sure. So we need, oh fuck, but I can't, not const then. Okay, that's fine. So an int reference, int ref1, int ref2, and then int x is 5 and y 1. Int temp. Sure, we'll say int temp. We'll say if int ref1 is greater than int ref2, int1 all cool. And now we can say else if int ref2, or we'll say it's greater, or so it should be, we're sorting. So we're sorting from greatest to least. Sort greatest to least. Greatest to least? I think that's how they say it, huh? Greater, lesser. Something like that. And we only need this guy here. And we'll say int2 is greater than int1. Sorting from greatest to least. And then we'll say temp is now, or well, int ref2, int ref1 is now int ref, hold on. So we'll store ref1. Int ref1 equals int ref2. Int ref2 is now temp. int1 ref, or int ref1 2 int ref2. Else int1 equals, or well, int1 and int2 are equal. Cool. Excuse me. Greater, lesser. It's already greater. Now let's say this is 1 and now this is 5, or whatever, fuck it, 56. Int2 is greater than int1, sorting from greatest to least, greatest to least. Int1 is 56, int2 is 1. Oh yeah, and then Pre-sort. Greater is 1 and lesser is 56. Int 2 is greater than int 1, sorting from greatest to least. Now int 1 is 56. Int 2 is 1. I swapped them. And now post sort is 56 and 1. What if we say 5 and 5? Pre-sort, 5 and 5 equal. Okay. How about that, huh? If or let's just say if greater, lesser, oh, I should have copied, not fucking. Okay. If greater is greater than lesser, and 1 is already greater than 2, cool. No changes. 1 is this, 2 is this. If lesser is greater than greater, and 2 is greater than 1. Sorting from greatest to least. Swapping. Or we could just say it should be swap if could just call this swap if unsorted, or sort to ints. Well, yeah, fuck it, I'll leave it. Okay. How do you return by reference and by address? It's pretty simple. Give the function an address, or, well, pointer return type, and make it return an address value, or give it a reference return type, and give it a reference. Make it return a reference. How do you return by reference and by address? A reference to an object that exists within the caller's scope to avoid a dangling reference. This is excuse me. Excuse me. Excuse me. 2.9. Oh wait, so what does that look like? A const pointer that wasn't ever defined. Oh, if it's const, it probably requires definition. That's what I'd guess. Really? Wait, what? Hold on. What do you mean? Oh, it's because it's defined to be null. Wait, what? Hold on. Requires an initializer. Operator type output stream and an int pointer, a constant pointer to an integer. Yeah. Makes sense. We basically just can't use const uninitialized ones. Excuse me. Const pointers are not reseatable and cannot be pointed and can't be pointed to other objects after initialization. Pointers to const are reseatable and point to modifiable objects that to modifiable objects that we don't want to be don't want to modify via the pointer, that we don't want the pointer to be able to modify. Non-modifiable objects where we must make the pointer const, prevent dropping the const qualifier from the object. Because the object is non-modifiable. Null pointers and null pointer is a pointer that, if dereferenced, crashes the program. Allows us to evaluate a pointer as a condition to check if null or non-null. Setting uninitialized, or well, setting pointers initializing unused pointers null pointer, and setting pointers to null pointer before destroying their pointee prevents us from using dangling pointers. Which exhibit undefined behavior, which dereferencing yields undefined behavior. Dangling pointers cannot be evaluated like this. A pointer is a I mean, I guess it's a variable, huh? But it's at least an object. Complex data type. Is it a complex or compound? Compound data type that holds the address of another object. We can set pointer, we can change non-const pointers to point to other objects as we wish at will. Can dereference the pointer to get or set the value at the pointee's location, at their address's location, and pass addresses to object addresses to functions to do the same without, while bypassing as objects to functions to and change caller object themselves by passing their addresses to functions which can dereference the addresses pointers. Lets us bypass copying expensive objects. Okay. Pass by L value reference and pass by const L value reference. Call the function. Well, pass by L value reference or const L value reference. Give the function a parameter, a reference parameter, or a const reference parameter, like int reference int ref, or const int reference int ref. This lets us access the value or the object's value at the caller's argument argument objects directly, be their addresses via reference binding. Double 4. Value reference to an L value reference to const is, holy fuck, it's already been 35 minutes. An L value reference to const, a reference to a non-temporary variable, or well, I guess a variable, yeah, a variable. To a const variable or a non-const variable that we wish to treat as const. Specifically, we have storing the oh wait, yeah. It's a reference to a const variable or non-const variable that we wish to treat a const, or an R value whose lifetime, I don't know if to say whose, but the lifetime of which will be prolonged, extended to match this references, the reference. An L value reference a non-object, the alias to an existing object. That lets us get or set its value at its address instead of letting function calls pass or return object values directly instead of copying, provided thinking about the standard string section we had where there were different types of conversions. So we could use a standard string. There's a standard string, there's that, and there's that. We use standard string because a reference I think when we use a standard string reference, we still have to convert something to a standard string, which is more expensive than converting things to a string view. Turn the fan on, it's hot. An L-value reference is an alias bound to an existing object. We can access or change the object's value via the reference depending on if the reference is an L-value reference to const, or well, if the reference is const or not. By passing potentially expensive copies of the object's value to function parameters, or from returned function temporaries to caller variables. Open to L values are, I mean, basically it seems like variables. Variables and R values are temporary objects. L values persist. Beyond, R values are destroyed after the line they're evaluated on, while L values persist until end of scope or programs end. Level 1. Compound data types are data types defined in terms of fundamental, of other data types, including fundamental data types. These include pointers, references, classes, unions, structs, and technically function types, since they, yeah, and more I'm ignorant about. We can call const expression functions at runtime like any other functions and pass them non-const expression parameters. Like, I mean, right? Yep. like any other function with or without constant parameters, with or without constant expression arguments. Use constant expression functions by calling them in contexts that require a constant expression, which will require the constant expression function to evaluate at compile time, moving load from runtime. Can also call them at runtime if used context where compile time evaluation isn't required. And we can pass them arguments known as them constant expression arguments or not. Best use is probably at compile time, at least to reap additional benefit. Doesn't hurt to make them constant expression and make them especially expensive functions. Constant expression, and to use them as much as possible in to try to use them only in constant expression context, even if some runtime contexts will also occur. Cheaper this way than all at runtime. Example, compiling shaders, maybe? Constant expression functions may evaluate at compile time. Is const eval oh shit. It's a variable that, yeah, okay, I was like, why is it? Oh, because it thought it was an unnamed function, I guess. Or x, oh, actually that's exactly what it thought. It thought that, no, maybe not. Never mind. Alright, well, never mind. Alright, so constant expression functions may evaluate at compile time if used in constant expression context, while const eval functions must evaluate at compile time. And require constant arguments that require constant expression arguments. 11.2. Oh, oops. F. Constant expression function is a function that can be called at runtime like any function, but also can be called at runtime like usual, or be called at compile time, or sorry, be evaluated at runtime. Oops. Evaluated at runtime like usual, or evaluated at compile time if used in a context that requires compile time evaluation. Objects created within must be constant expressions, or variables created within must be constant expressions, since constant expression functions can be evaluated at compile time. 11.10. Excuse me. how to use function templates in multiple files. Excuse me. Oh yeah, don't we just treat them like inline variables? I think templates are implicitly inline, isn't that the point? So we could do, how long has it been? 50 minutes? Sheesh, 40 left. Let's do, let's do or rather, this doesn't help. Really what I want. Yo? Yeah, I'm just going to define it here and for declare it elsewhere. Yep. Seems like they have internal linkage, but are also inline. I think that's how that works. Like a static function. Function templates have internal linkage and are implicitly inline. So the best way is to define them in header files, include the header files in all .cpp files that will use the functions, requiring the functions, or using the that use the functions. We don't have to make the, and that's it. Find them in header files and include the header. Well, find them in header files and include the header files and also use the functions, giving the linker will deduplicate the definition. Is there even a point? The definitions. Well, are they implicitly inline, meaning? Oh, meaning that they're automatically inline expanded? Is that how that works? Functions are implicitly inline, allowing multiple identical. Oh, how does that work though? If I have calls in one file and calls in another file that. Oh. I think that's fine. Inline requires that the definitions are identical in multiple files. So if we have overloads in one file, 3 overloads in one file, in float double, and then I have int and float in another, and it doesn't have a call to a double, or it has a call to standard string, then it's fine. Any of the identical ones just must be identical. But there's no conflict between the standard string one not existing elsewhere. The linker Well, if they're internal linkage, then so we define them in header files and include them in also. I think that's fine. Here's a test. Number 1. Oh wait, no, fuck, not that. Alright, well. Template 1. Template 1? What happens? Nice, alright, cool. I just want to see. Template 2. Namespace addition. Void, template, type name T. T, add, I think I screwed up earlier. TX, TY. Return X plus Y. X plus Y. Cool, and then we can say double D is add 1.3 plus 4.3. What? What are you talking about, bitch? Oh, is it because we actually have to call it in the file that it's included? Wait, huh? Why is this not? Is it just because it's not known at compile time? So if I did 1 and 1 and int, still not good. But if I'm gonna test this real quick. And then what if I had a function void test and x is add 3, 4 or 3, 2. So that's cool, but it's not cool to have it. So it needs to be in its own function so that it's called. So if this was const expression, it wouldn't work. Cannot, because we can't call add until. So if add had int add int x int y, return x plus y, then and then it's cool because this guy's already known. Cool. But that's fine. Alright, nice. But then if I made this double 2.2, 2.1, sure. Already defined. Gotcha. Okay. Oh, the problem is that, hold on. Oh, well, the problem is the void part. Damn. Now these are cool. So I guess these are implicitly, they have internal linkage, so I don't have to worry about them. I guess the inline part doesn't matter. Internal linkage. So we define them in header files and include them in all, which get included in all .cp files that need them. Function. non-type non-type template parameters are typed template parameters that require constant expression arguments that we pass with syntax that we initialize with syntax during calls with syntax func 34 or value arg1 arg2. And I guess pointers and references, maybe they can, if we know where things are going to be initialized, if we make them static, maybe they work for static stuff, but I don't think they work for constant expressions. So like, I don't know if there's a constant expression pointer returning function, because it's not in memory already. I'll test that in a sec. What are they even helpful for, really? I mean, because I could just make a const eval function and then give it values that are constant expression. I'll let it tell me what they're useful for. I personally don't find them useful yet, because I mean, I could just do const eval void do thing index like, is there a fucking point? I don't know. Oh, so that I can initialize. Gotcha. They let us pass const expression values to functions. That way we can initialize const expression variable initialize local const expression variables with them, which normal parameters are disallowed for, since they can't be made const expression. How do you use function templates with multiple template types? Meaning multiple, like type name 1, type name 2? Give the function multiple type name parameters and call the function with same or different type parameters, i.e. template type name t, type name u, would do thing, t x, u y, do stuff. Function template instantiation works by generating an instance an overload of the function, a unique overload for the function for each unique call that has a unique number of parameters, or matrix of parameter, or combination of parameter types, yielding different overloads that will be called by calls that best match them. Calls that they best match. A function template is a function that generates instances of itself with the same logic unless explicitly specified by making an explicit template specialization, i.e. hard coding and a unique version of it with logic differing from the primary template, function template. The same logic but different parameter types to match each function call with a unique combination of parameter types or unique parameter or argument count or parameter type combination. Default arguments are values that function parameters are initialized with. If the call does not, if the call omits the argument for that parameter, i.e. I could call this function void do thing in x is 5 with do thing this to use 5 to initialize, to use the default argument and initialize x with 5, or call it with another integer or value that converts to 1 to change the value of x. Deleting a function means disallowing calls to it, means preventing calls to it from, means making calls to it yield compiler errors, compilation errors, i.e. take a function signature with a body, a function signature, and end it with equals delete and remove its body if it formerly had one, and this will yield compilation. Will prevent compilation if any calls to that overload or function remain when compiling. 1.3. Overload resolution is the process by which a call, a function overload is matched to a call to the function. It's matched to a call. This is done by comparing how well it matches to, well, occurs by compiler, well, using a hierarchy where an overload, with parameters that directly match the call arguments will be called first, then others that most closely match. Prioritizing numeric promotion, short to int, not int to long, short to int over numeric conversion, int to long, long to int to to a double, etc. And more exact matches and more close matches over less exact matches and less close matches. Okay. Ambiguous matches arise when when multiple overloads are equally match a call. Meaning that there isn't a direct match because we'd get a redefinition error. And the conversion that occurs to call and a conversion step that finally yields a best match function actually yields two best matches. Number two, by comparing the arguments, call arguments to the functions. The best match is called, or a compilation error occurs if match is ambiguous. Function overloading is using one identifier among multiple function versions that differ in parameter count or data type. 10.9. Use auto as the return type, and the return type will be deduced, to match the data type of the returned value. 10.8. Use auto as a variable, as an object's data type, and it will match the data type as the initializer of the initializer. 10.7. I need to blink more. Type defs and type aliases let us refer to data types with different identifiers. Maybe potentially increasing clarity. Making calls to complex, lengthy types more convenient. 10.6. Static cast target type, initial type value. Sorry, this should be final type value with initial type value. Nope. 10.5. Arithmetic conversions occur when the usual arithmetic conversion rules. Which are used to identify the common type when operands of binary arithmetic operators are different types, i.e. add 1 this returns 4.2 because the rules convert integer types to floating point types via arithmetic conversion. 10.4. Narrowing conversions are conversions of our convert data of type A to data of type B. Conversions are conversions of data of type A to data of type B, where type B can't represent all values of type A, potentially yielding data loss. 3. Numeric conversions occur explicitly or implicitly when calling function with an argument that doesn't match the parameter type, or initializing, assigning a variable the value that doesn't match its data type. This converts data of type A to data of type B if the implicit conversion isn't disallowed by, well, forbidden. Isn't narrowing. If the conversion isn't narrowing. Well, hold on. If I for implicit types. Cool. Well, hold on. Numeric conversions convert data of type A to data of type B. Like when initializing a float with an int, or vice versa. Lossy conversions warned by the compiler. Well, passing an int to a function expecting a float. — 15 minutes. Okay. It's how data type mismatches are resolved implicitly. Allowed if not unsafe, or explicitly to bypass unsafe conversions, like from 2.0 to 3, if done at runtime. If done not using const expression variables. Without at runtime. Floating numeric promotions are when data of an integer or floating point data is numerically converted to match its destination or common type during arithmetic conversion. Yep. when the conversion is safe and involves and yields a wider type that is more preferred by the architecture, like int bool to or like short char to bool, float to double, float to double. Symbol 1, implicit type conversions are when the function parameter expects an argument of type A, but it gets type B, or when initializing or assigning a variable with type A when it expected type B. Sometimes disallowed if unsafe. Let's do some super fundamental stuff. 1.1. Skip the bit. 1.1. A statement is an individual instruction for the program. And then semicolon. Main executes the program and all it does eventually returns to, and all calls from it return to main, where the program will eventually terminate if not terminated early. 3. Comments are ignored by the compiler and are used to improve rebuilding. Okay. Code is executed by the compiler. Single line and multi-line. Well, is there a way I can fuck? Nope, there's not. Oh wait, nope. Fuck. Can I do that? No, I cannot because that's still into act. Whatever, it's fine. It's gonna, yeah, it's weird. Alright, whatever. 1.4. Variables are named objects. Data type, then name, then initializer, or no initializer if not const. Bool, test, true, int, big dick, 3, 35, pop, 1.5. Assignment is assigning value to a variable, well, to a variable after, well, yeah, because I have to refer to it. Well, yeah, it has to be a variable because temporary objects can't be assigned values. I'm thinking of an L value reference to const with an R value. And we're using a const reference and it's a temporary, so we can't change it, yeah. Assigning value to a variable after definition, while initialization is assigning value during during definition. Excuse me. Standard character output outputs characters to the terminal console. Standard character put inserts extracts characters from user input to whatever variable it's being extracted to, and standard end line adds an end line character to go to the next line, but also flushes the buffer. Okay, pop. Don't have any more time. Uh-oh. Oh, that scared me. Alright. Oh, well, motherfucker, of course. Hold on, wait. Oh, we did call it that. Okay, whatever, it's fine. I missed that. I forgot I was referring to him a million more times, but it's okay. In ascending order? Motherfucker, you did not say that. You just said to sort to integers. That's fine. Side effects? Print output. Should only swap the values and not print anything. Okay, buddy. Fuck you. Missing simplicity? Yeah, I guess we would. Wait, what? Swap? Man, I ain't using no damn standard swap. Man, how about we just do this, huh? If that's what you want, not saying anything. And man. We don't even need it, man. It's fine. We'll just say void. We're just saying, yeah. Void. Void sort to ints. And I'm going to say an int reference int1, int reference int2. And if int1 is less than int2, int temp3, well, whatever, value initialize, what am I doing? Int1 is now int2, int2 is now temp, and this should actually be temp is, and this should be initialized with int2. Int main. If you're doing swap, one, you're doing it on the same line, and two, you have to set one to be the other, and one to be something else, and you need another variable, so you need 3 lines there. And you need 2 more because of that, that's fine. Alright, mine's cool. It was just a shitty question. Making a local variable static can extend the lifetime. Yeah, makes sense. You did not mention returning references to pointers. Return a reference to function parameters. That way we're returning stuff that already exists. Return by reference versus return by address. We're returning a fucking reference versus returning an address. Yeah, it's fine. Pass by address means passing a pointer. Pass by address? Oh, I fucking miswrote. It's fine. I'm tired. To explain that pass to address must be pointer. Yeah, exactly. And you pass the address of the non-pick. Yeah, exactly. Quick stay. Hold on, here we go. Pointers to constant receivable. Okay. Not distinguish between. It's a const pointer, can't change. Constant pointer. Yeah, I said that exactly. Pointer to constant receivable and point to modifier object, so we don't want the pointer. Yeah, exactly. That's a pointer to const. Oh my god. Well. Alright, I'll go a little bit more. Well, the whole point here is to try and correct my misunderstanding. Alright, or any issues. Alright, this is fine. Statement. Well, I mean, they can, sure, yeah, we can, but I'm saying that we can't. I'm saying we can't evaluate them to determine if they're a dangling pointer or not. Yeah. Well, I mean, probably. It's. Alright. It may crash the program, but it's undefined behavior. Yeah, sure. Alright. Pointers holding addresses, they're referenceable. Hold on, wait. Yeah. Pointers can be null, yes. Can be used for dynamic memory. Yeah, I don't know this. That's fine. Did I mention benefits? Avoid copies. I've said that in other ways. That's my concept value reference. They don't allow modification. Are you fucking stupid? Find a temporaries? Yeah, exactly. I said that earlier. The problem here is it asks a bunch of questions about things that I am like it'll ask some simple questions and then a complex one, and I'll answer the complex one with answers that I already included, or answers about the simple ones, but then I won't answer the simple ones because we're going backwards. That's the only difficulty of starting backwards. I answer this with all this information, and then I answer with not all the things that it wanted. It's just stupid. It's just an AI issue. It's fine. Then I mentioned this is how they can accept. Yeah, exactly. Reference to concept. Yeah, exactly. Yeah, I can do that. That's exactly what I just, yeah. Well, and duh, why else would he do it? Preferences, L value references. Wait, it has to be a reference to a const. L values addresses. R values can be literal, temporary. Exactly. Gotcha. Yeah, I don't know what arrays are. Can be used in context version. Well, yeah, if they're compile time use, they can be used in compile. Are you stupid? All code paths. It's not true. At least one does. Function templates do not have internal linkage. They have external linkage, but must be defined in headers. Oh, okay. So they have external linkage. If they have external linkage, but they have to be defined. So the point is that we put it in a header. The linkage doesn't matter then, right? Oh, so the point is that, okay, compile two different files. The code means that they're going to get two identical overloads. They have external linkage, so they're going to conflict, so they're implicitly inline, so they get deduplicated. It's just that I can't tell. I don't have two mains to actually put data in to test the two functions to see if they get fucked up or not. Okay. Can I? I'm not sure. I thought I tested this earlier where I had two different CPP files. Oh, that's the problem. Yeah. The problem is that I actually have to compile it, and that's when the deduplication happens. There's no way for me to have the like. There's no way for me to have the two functions, compile them so that the instantiations are there, and then see them be deduplicated. So this all happens implicitly. One file ends up needing an add int int, another file ends up needing an add int int. They both have the template function included from a header file, and oh, it generates the same guy, the same function, I'm not going to see it because it's generated. That's after compilation. I can't see the code after compilation because it doesn't actually change the code. It changes the binary. And then they deduplicate it so that there's only one definition, so we're not violating the one definition rule because they have external linkage. Okay, so they are implicitly inline. Okay, have external linkage, but they need to be defined. Gotcha. Okay. And then it gets deduplicated later, so it's fine. On template type parameters. Well, I mean, dude, they're kind of stupid. Terminology, the result is not an overload. Well, I mean, dude, it's the same shit. It's a function. Well, it's a separate version of the function, so it's called a function instance. It's an instance of a template function where we can explicitly call it in different ways with the template type specified, with it deduced, but only considering template parameters, or left alone to where it'll prioritize. It's deduced, but it'll prioritize non-template overloads first, non-template versions. I mean, alright, fine. They're called template. They're specializations versus overloads are made manually. But this is a way of making the overloads just get generated, so it's similar enough. Ambiguous matches. Okay, I literally said this somewhere. Return types. The trailing return type. Yeah, okay. You could also do auto for that. Yeah, I mean, I usually put that, but I didn't do it every single time. Incorrect. Short character to. Bro, I literally said not short character to bool. Not that, because that's a numeric conversion. Cool. Alright. No issues, really. Just gotta get better at communicating this stuff clearly to make the AI happy, maybe. Maybe not, but I understand the stuff, so cool.